Alright, we're going to jump right in here, and I know there's a lot of information here on the page, so let's talk about some things. This is probably what you've been taught before, multiplication counting principle. So if there are m ways to make a first selection and n ways to make a second selection, then you multiply the two to find out how many ways you can make the two selections, right? So example, 5 shirts and 8 pair of shorts. So how many possible outfits can you make, assuming they all match? 5 times 8 is 40. So this is the type of thing that you've done before. Now I'm going to up the ante a little bit, because if I jump down here first, okay, these type of problems down here, this is no problem for you. Okay, we'll start at the end here. A sandwich menu offers customers a choice of white, wheat, or rye. So white, wheat, or rye, that's 3. With one spread chosen from butter, mustard, or mayonnaise, that's 3. How many different combinations of bread and spread are possible? Well, 3 and 3, so 3 times 3, that's 9. And you probably don't need me to explain that much. For their vacation, the Murray family is choosing a trip to the beach or to the mountains. That's 2. They can select their transportation. Okay, so the trip itself and then the transportation. Car, plane, or train, that's 3. How many different ways can they select the destination followed by the means of transportation? So 2 times 3 is 6. So what you'll start to do, hopefully if I do my job well to challenge you a little bit, is how many answer machines allow you to call home and get messages by entering a 3-digit code. How many codes are possible? So here's what you have to think. Well, here's the first digit, and the second digit, and the third digit. And they can be anything we want them to be. But here's the idea is how many possible different numbers could go in here? Well, we have a single digit, right? So we have 1 to 9, but we also have to include the number 0. So what I have to remember is that this is going to be 10 choices, and it doesn't say anything about repeating or not repeating. So we're going to assume that we can repeat. So I could use like 3, 3, 3 if I wanted to, which means I have 10 choices for the first, 10 choices for the second, and 10 choices for the third, which gives me a possible 1,000 choices to make up my code. Now that's only if it's a 3-digit code, so you see why most things often use a 4-digit code, that type of thing. So that's your counting method. So the other two main ideas we have today is a permutation is an arrangement of items in which the order does matter. So that's the key. The order does matter. And I'm going to try and give you a bunch of examples and try and clarify all this stuff for you. Okay, but if we have a permutation, we use the letter P. So N is the number of items total. R is the number you're picking. Okay, so you might say down here this is total, and R is pick. So permutation, the best example of all of our permutations is when we talk about running a race. When you run a race, we have first, second, third. Anytime we talk about an order, matters. Now, the other side, or the flip side, a combination of n distinct objects that are taken. So that means if you're being selected onto the homecoming court or student council. Okay? So you don't have the president, the vice president, all those things. You just have 5 people that represent your class, or however many people it is. So that is just a combination. So here we're just selecting them. Same thing, n is the total, r is how many you're picking. And we'll get into this factorial. I'll show you what that is in a little bit here. So the first thing we're going to do is identify if it's permutation or combination, and then we'll pull the calculator up and see how to do that. So 8 people enter the best pie contest. Okay. Now it's just a pie contest, it's not a pie eating contest. So how many ways can blue, red, and green ribbons be awarded? Well, first thing is, what does it mean? Blue, red, and green, right? Blue means first, red means second, and green means third in this case. So if we have first, second, third, that means it's automatically a permutation. We have 8 people, so we have 8. And how many ways can we award first, second, and third place? So we're going to pick 3. So that's the first thing. So we're going to leave that set up until we get the bottom one done. 5 cousins at a family reunion decide that 3 of them will go pick up a pizza. How many ways can they choose the 3 people? Now, are these people going first, second, and third, or are they just going? So we have 5 cousins, and we have 3, and is there an order to them? No, there is not. So if you can say there's no order, then it's just a combination. Alright, let me grab my calculator. Alright, I got my calculator back now. So here's what we're going to do. We have 8, and I'm going to go through math, and I'm going to go to the left because it's faster. I want the PRB, probability, and here you see NPR or CPR. So I want NPR because we're dealing with a probability. So I can hit 2 and then enter, or I can just hit 2. And I have to tell it how many I'm going to pick. I'm going to pick 3. So that means I have 336 ways to award first, second, and third place. Now while we're doing this, we'll also do 5. And here's our math. I'm going to go down to C for combination and hit enter. And 3. Okay, so I have 10 ways. So 336 and 10. 336 and 10. So probably a couple things we want to talk about here is, if we're talking about the order, if the order is specific, which way is going to have more options? So to practice that, or to demonstrate that, I'm going to go ahead and do a a combination using the exact same numbers as the first problem. So if I had 8, choose 3, and I'm just picking them, notice we only have 56 ways to choose 3 people out of 8. But if we're going to put them in an order, like a permutation requires, now it's 336. So permutations are always going to have a lot more, provided we have enough people and we're choosing a smaller group. We get a lot more choices. Now the last thing we should probably discuss is factorial. So let's use 4, and you probably saw it in there under probability down at 4. So 4 factorial, and it's 24. So let me show you what's happening there. And we can put this anywhere. I think there's an example later in your notes here. As a matter of fact, I'm sure there is. So 4 factorial, we said is 24. Well, what it actually is 4 times 3 times 2 times 1. Right? Notice we're starting with that first number, 4 factorial. So 4 times 3 is 12. 12 times 2 is 24. 24 times 1. So it multiplies the whole way down. So when we look at back here, we gave you some factorial in the equations. If we had to use it that way, we could do that. But for the most part, we have the scientific calculator. We're going to use it this way. Okay, so again, the whole key for the most part is to try to identify what it is permutation combination. That's the hardest part. After that, it's calculator work. From a group of 9 different books, 5 books are to be selected and arranged on a shelf. So we have 9 books, and we're going to pick 5 of them. How many arrangements are possible? Yeah, I'm not just going to pick the 5 books, I'm also going to arrange them. Okay, arranged on a shelf. So that means you're going to put the first one down, the second one down, the third one down. Okay, so that is now a permutation. How many different orders can 10 dogs line up to be groomed? So we have 10, and we're actually going to choose all 10, and we're going to put them in different orders. So that's a permutation. Suppose you want to arrange 6 trophies on a shelf, selecting from your collection of 15. How many arrangements are possible? So 15, again, it's arrangement. So we start to identify some keywords. All right, let's get some answers for this stuff. Okay, so we had 9, and we're going to do a permutation. So here I use 2 instead of doing that. 5, and hit enter. All right, so 15,120. 15,120. Yeah, we start to get some pretty big numbers, eh? All right, 10, choose 10. So 10. Permutation, so that's 2. And we're going to pick all 10 of the dogs to line them up. Where my dogs at? Oh my gosh, here we go. So we have 3,628,800. And for the last one out of my trophies, I'm going to get 3,603,600 ways to do that. Okay, so going through the same thing. A group of 7 students working on a project needs to choose 2 from their group to present the group's report to the class. How many ways can they choose the 2 students? So we have 7. They're going to choose 2. Are they choosing a first place and a second place, or are they just picking 2? Just picking 2. Combination. Okay, so we'll get a combination of 21. 10 finalists in a figure skating competition. You got a couple more years till the Winter Olympics. Hope you enjoyed the Summer Olympics. How many ways can gold, silver, and bronze medals be awarded? Well, what does gold, silver, bronze mean? First, second, third. So we have 10. We're going to choose 3, and the order matters, so it's a permutation. So we have 720. So what I would like you to do in your notes here is give an example of a permutation in life. We've talked about a couple different ones. The Olympics are a pretty good one. Try and come up with something that I didn't tell you about. You could even pause the video and Google it if you want. Try and come up with a permutation application in life. Google it, see what it says. All right. Here we covered factorial, so we're in good shape there, right? N factorial, so it's not an exclamation point in math class. It's called factorial, and that means we're going to have the product, which means multiplication, of all the numbers from n down to 1. All right, so all I want you to do with this next part, well, let's go through these together. We'll do some more in class together. We just want to identify permutation or combination. For a super value lunch at Deep Fried Dan's, sounds real healthy, right? Choose 3 things from the 20 item menu. 3 things from the 20 item menu. So we have 20 items. I want to choose 3. Does the order matter? Absolutely not. So it's a combination. 9 people are running for president and vice president. Most people would say the president came in first and the vice president came in second. That helps. So 9. And we're doing a permutation to choose 2. Out of 100 people, the first 5 to show up at the radio station get tickets to the AC/DC show. That's kind of a dated problem. Do you guys even know who AC/DC is? Anyway, so we're going to have 100, and the first 5. The first 5. What do you think here? So we do have a permutation. Because they're not going to choose 5 out of it. It's the first 5. 1, 2, 3, 4, 5. You guys are it. 12 people competing for gold, silver, bronze medals in the burping competition. They must have went to Deep Fried Dan's up top there. Okay, so gold, silver, and bronze, that's 3 places, and they are in a very specific order permutation. How many different ways can 5 people stand for a photo? So you have 5 people and you're going to choose all 5. So different ways can they stand? So that's permutation. We'll get some values for this. We'll practice the calculator in class. I don't want to bog you down with that right now. Most important to see the difference. Different ways. How many different batting orders can you have with 9 players? So 9, choose all 9. We do have to bat all 9 of them, so that is a permutation. The band has 7 new songs and wants to put 5 of them on the demo CD. How many arrangements of the 5 songs are possible? Arrangements, keyword for permutation. Good. 20 people report for jury duty. Okay, so you notice as I get the information, I'm just going to pull it out. How many different 12-person juries can be chosen? So we want different juries. Okay. Now, if I pick Billy, Susie, that type of thing. If I then pick Susie, then Billy, instead of Billy and then Susie, that's still the same jury. So here what we're talking about is a combination. So when we say different, we want to be very careful with that. Different doesn't mean I arrange them different. How many different ways can you choose 3 types of flowers for a bouquet from a selection of 15? So I have 15. I'm going to choose 3. So since we're talking about different ways to choose them, when we start to say ways, that's always a key for a permutation. Alright, let's see where we're at here. Try and get a little bit of understanding. Do you know how? Find the value of each expression. So what we'd like you to do is, if you have a scientific calculator, which we all should, is go ahead and work through that. The keys are all the same as what I showed you on the TI-83. How many outfits can you make with 6 shirts and 4 pair of pants? You can probably answer that right now. So vocabulary. How are permutations and combinations similar, and how are they different? This is actually a great question. This is actually probably better than our vocabulary question. And we'll try and figure out why, we'll talk about this one in class, okay? So save that one for me in class.